Good morning, everyone. Good morning. Hope all is well. Yep, trying to scan to make sure everything is holding true to what I was told. Always gotta make sure I know who's in the room when it comes to you guys. So we got rescheduled, guys. So my dean is not coming in today. Um, so got rescheduled all the way to October 27th. So, which is cool because I actually had a dentist appointment that I found out I had, and it's hard to move those things anyway. That a dentist appointment go all the way to January, So we'll just go over one section today, and then I'll take all try to make that appointment and everything. So, we should be all right. Let's see, trying to make sure everybody's in here. Morning, good morning. All right, so and of course my notes not up. Come on. There we go. Ooh. So last class we closed out 3.4, and today we'll look at 3.5. Yep, I should be in my office hours today. Yep. All right. So we're looking at rational functions and their graphs. So just like I mentioned before, when it comes to graphs, at this point, they pretty much we're pretty much comfortable with graphing and believe that you're pros at graphing, and graphing by hand isn't the focus anymore. So you just need a graphing tool, graphing calculator, or something online that you can use and reliable in order to be able to make these graphs for you. If you have to verify, if my math lab asks you, is this the graph of this, just plug it into a graphing tool and you should be able to verify in that fashion. So what we're talking about today, though, that may be new for some of you, are asymptotes. Hold on 1 second. Sorry about that. So asymptotes, there are places where the function is undefined or does not exist, or in other words, there are places where the graph does not cross. So here's just a rough sketch of what I mean by that. You have your graph where it'll, as a matter of fact, I'll just erase this. You'll have this invisible line, and your graph will never cross it. It will, go up or go down where that line is and never cross that line. And so those are your asymptotes. Mm-hmm. So we have three types of asymptotes: vertical, horizontal, and slant. Some books call them oblique, but slant asymptotes and oblique asymptotes are the same thing. All right, so let's look at finding the first type discussed, the vertical asymptote. So your vertical asymptote is going to be where the denominator is equal to 0. So the way we will find them is first we're going to simplify our expression as much as possible. Then we'll set our denominator equal to 0 and solve. Okay, first example under this is we want to find the vertical asymptote, if any. Excuse me. First one is f of x is equal to x over x squared minus 9. So first step is simplify as much as possible. There's nothing that simplifies with this. You know, if you were to factor that denominator out, you know, nothing cancels. So you just go ahead and just take the denominator that you have, set it equal to 0 and solve. So x squared minus 9 equal to 0. That can factor out to give you x plus 3x minus 3. Set both of those equal to 0, solve, you get x equal to -3 and x equal to +3. So we will have two vertical asymptotes in this case. And here, just a rough sketch of what that may look like. You have these invisible lines, vertical lines at x equal to 3 and x equal to +3, and then your graph would never cross, you know, those lines. And so, you know, this just helps us establish what are those lines, where, you know, where those invisible lines would be. Any questions? All right, can you scroll up a little? All right, the next one is x plus 3 over x squared minus 9. That's the original problem right here. So I factored out the denominator, and we notice the x plus 3 can cancel. I'm gonna try to be color coded on what happens next. So the x plus 3 cancels, and that leaves us with 1 over x minus 3. So what's left? The x minus 3 will produce a vertical asymptote. But the part that cancel out, you cannot, you know, just negate the fact that it was ever there. Remember, it was a part of your original expression. So the x plus 3 will produce a restricted value. So in other words, remember we had graphs before they had an open circle. That's where an open circle would be at x plus 3. So, you know, you set that equal to 0 and solve. Now, if they ask for the asymptote, all you're going to do is, you know, use x minus 3 to find the asymptote. But if they ask you for any restricted values, then the x plus 3 will produce that restricted value. So everybody done with that last problem? Mr. Bracy, see you in here, man. I think you missed the announcement that the dean didn't come today. We got rescheduled, sir. So you can still, you know, you can let your hair down, sir. It's all right.
I changed my background image and everything.
So we see that x plus 3 gives us our restricted value, and then x minus 3 gives us that vertical asymptote. All right, let's go to the next one. X plus 3 over x squared plus 9. So before we had x squared minus 9, we could factor that. Here we have x squared plus 9. Cannot factor that. without involving imaginary numbers. So we can just go ahead and set that equal to 0 and solve. And we see that our solutions end up being imaginary. And since that's the case, that means we don't have any vertical asymptotes.
Why can't you factor it?
Because notice how we get imaginary terms here. That's an indication right there that we wouldn't be able to factor it without involving any type of imaginary numbers. Because remember before when we did our solving, we ended up getting a positive 3 and a negative 3. Those are real numbers. So that means we would have been able to factor that with real numbers. But here, that getting these imaginary numbers, whenever you take the square root of a negative, it's going to give you that I.
Okay,
and,
gotcha.
Yeah, and so since that occurs, that just solidifies the idea that we cannot factor. Now, I will say this. Not being able to factor does not mean you will never have a vertical asymptote. Sometimes if it's irrational, then that will be the case as well. But you still wouldn't be able to factor it, but you would have vertical asymptotes like that are 3.157, something that's long. That's something that they wouldn't consider factorable, but you would just have a run-on decimal for vertical asymptote. I don't think they're going to take y'all there like that, but I was just saying, not being able to factor is not us, just, oh, I can't factor, so no vertical asymptotes. No, what really produced the ability, what really produced the scenario of not having a vertical asymptote was the imaginary number.
And the imaginary number came due to the positive sign being on the bottom.
Yeah.
Plus 9 instead of minus 9.
Right, exactly.
Which meant that when you put it in the square root, imaginary number.
Mm-hmm. Mm-hmm.
VA means vertical axis, right?
Vertical asymptote.
Acetone. What does RV stand for then?
Restricted value.
Yeah.
Mhm. All right, can we scroll up some? Anybody holding on to see? All right, so let's look at a horizontal asymptote. So first, we're going to let n be equal to the degree of the numerator. We're going to let m be equal to the degree of the denominator. So when you say degree, we're talking about the highest exponent. So the highest exponent in your numerator, highest exponent in the denominator. It's going to dictate our actions here. All right, first scenario, if the degree of your numerator or highest exponent in your numerator is less than the highest exponent in your denominator, horizontal asymptote is 0. Also take note, we have y equals. Before, when we're looking at vertical asymptotes, we had x equals. So that does matter. So your vertical asymptotes is always x equals. Your horizontal asymptote will always be y equals.
You go over the beginning part again, where you were saying the rules, like if blank equals greater than this, then this.
Oh, right here. Yeah, if the numerator, highest exponent in your numerator is less than the highest exponent in your denominator, y is equal to 0 for your horizontal asymptote. So no calculation, just observation of what you have. And you recognize you have that scenario, y is equal to 0. If your exponents, highest exponents in each are equal, then you're just going to take the leading coefficient of each. And once again, it's y equals. So. And then last scenario, if n is greater than m, numerator's exponent is greater than the denominator's exponent. There is no horizontal asymptote. Instead, we will go to your slant asymptotes. Any problems, any problems? All right, scrolling up some. So when to find horizontal asymptotes, if there are any. So the first one, 4x over 2x squared plus 1, and of course this one for the exponent wasn't there. But I wrote it there just to make sure we understand that if you don't see anything, they assume you know there's a 1 for the exponent. All right, so our numerator, highest exponent in our numerator, we calling that n. Remember, in our denominators, highest exponent will be m. Excuse me. So n is equal to 1, m is equal to 2. So we have the scenario that n is less than m. So my horizontal asymptote is equal to 0.
Wait, can you like, okay. So n is the exponent of x, and m, I mean exponent of the numerator, and m is the exponent of the denominator.
Mm-hmm.
All right.
Anybody else before we go to B? All right, so here we have 4x squared over 2x squared plus 1. So both of our exponents are the same. Whenever your exponents are the same, you take the coefficients of your variables, which was this 4 and this 2. That's what we did here. And 4 over 2 simplified to 2. Don't forget we're doing y equals for horizontal asymptotes.
And it ignores that plus 1 there, just 4 over 2.
Yes. All right, any problems before we go to C? C addresses our third scenario. Notice we have 3 for our numerator, 2 for our denominator. As far as our exponents are concerned, the degree of our numerator and denominator be 3 and then 2. So n is greater than m, so that means we do not have a horizontal asymptote. And that's going to take us into finding our slant asymptote. So for the problem that you guys will have, you will not have a horizontal asymptote and a slant asymptote. So it either be one or the other. So you can have a vertical asymptote and a horizontal asymptote, or a vertical asymptote and a slant asymptote, but you won't have a slant and a horizontal. Like both of those are not going to be able to exist for you guys with the problem that you guys will get. So just keep that in mind. You know, so you find yourself with a horizontal and a slant asymptote somewhere you went wrong. So. Any problems, any problems? We're done with B. All right, so let's look at our third asymptote. So when N is greater than M, there should be a slant asymptote. So we'll use long division or synthetic division if possible to find. Anybody holding on to C? All right. So then the last part of that, so it will take on the form, like whenever you divide out, remember you have your answer part, then you have your remainder. So the answer part is actually called the quotient. So your slant asymptote will be the quotient. And so everything before the remainder. And notice, once again, we're doing y equals here. Remember, it's either slant or horizontal. Both your slant and horizontal use the y equals. So it will be y equal to whatever the quotient part is. And you don't include the remainder when it comes to your slant asymptote. All right, can we go to an example? Everybody good? All right, so it says find slant asymptote. So notice that our numerator's exponent is higher than our denominator's exponent. And since we have the form of x minus 3, I just went ahead and used synthetic division here. So if it's minus 3, that means this needs to be positive 3. Set up your coefficients according to what you have here. 1, -4, and -5. So bring down your 1. 3 times 1 is 3. Add those together, you get -1. 3 times -1 is -3. Add them together, we get -8, excuse me, that's our remainder. And so our answer, you always start off with 1 exponent less than what you originally had. So it's going to be x minus 1 plus -8 over x minus 3, that's your remainder. And so remember, everything before the remainder would be your slant asymptote, and that's what we have here, y equals to x minus 1.
Can you re-explain that one more time? I just got lost.
Explain what, the synthetic division?
Yeah, like, okay, where all the other numbers come from, like the -4 and -5, but it doesn't seem like you used them unless I missed something.
Okay, so you're saying where these came from, or the numbers?
Yeah.
Okay, so those came from right here.
Okay.
All of those coefficients, 1, -4, -5. And then the process with synthetic division, you bring this one down. And then you do this times this, which is multiplication.
Okay.
And then the result goes here. Then you add these together. That's how you get this. And then you
Oh.
repeat that same process. 3 times -1 goes here, which is -3. Then add these together. That's how we get -8.
Okay. Thank you.
Mhm.
Okay, how do we determine that you can use synthetic division? I missed that part.
This has to have a 1 in front of it and a 1 for your exponent. If anything's different, then you cannot. So in other words, if it was 2x, you wouldn't be able to do it.
So it just has to be like the variable, either plus or minus a
A
number.
number. Yep.
Okay.
Do you need the plus -8 over x minus 3 for anything?
Not for this.
Because it seems like as soon as you get the x minus 1, you've got your answer, so you don't really need to go through the rest of it.
Yeah, not for this. So I'm just solidifying the process because just like we had people ask just now the question about it, I didn't want to leave off a part of it. Then they see it back in 3.1 and then leaving off parts of, you know what I mean? So I just went through the whole process, right? So for this section, all you need is this part. But back in 3.1, where this process is discussed, you need the whole thing. So yeah, yep, absolutely correct. And so somebody asked that last class too. Once again, I just want to make sure I reemphasize the fact that in this section, all you need is the x minus 1. But back in 3.1, when we talked about long division and synthetic division, you need the whole thing. So, just make sure, you guys hold true to that. Make sure you read the directions. So if they just ask for the slant asymptote, that's all they need. But if it says divide, they need the whole thing. Yeah. All right, let's do it at least one more time. So the next one, we have x squared plus 1 over x minus 1. So don't forget, it is possible to have missing terms. Notice how we go from x squared to just 1. And the missing term here is x. Because it should go in go by ones all the way down to not having a variable at all. So it should be, if it's x to the 4th, then you should see x cubed, then x squared, then x, and then no x at all. So here we have x squared and it skips our x term. So we put a 0 there for a placeholder and use the coefficients that we see. So there's a 1 in front of x squared, and of course that's plus 1. Once again, we have x minus 1 down here using the synthetic division. So I'm going to do a positive 1 in the box. And then we'll follow the same procedure. 1 times 1. Remember, that's multiplication for that part. And then you take that value right there. So 1 times 1 is 1. 0 plus 1 is 1. Then 1 times 1 is 1 again. And then 1 plus 1 is 2. Start off with one exponent less than what you originally had, which would be x to the 1st power. So x plus 1 plus 2 over x minus 1 would be the whole answer for the division, or the whole result for the division. But the answer that we need is just the x plus 1. That's our slant asymptote. Questions, questions, questions.
What are we doing with the rest of it? Like the 2 over x minus 1, like what is that?
Oh, put it in your pocket, save it for later. Yeah, we don't need it for what we're doing here in this section. We don't need it for this
What is
section.
it called? Like
Oh, that's your remainder.
2. Okay, that's just the remainder.
That's just the remainder. Yeah, this last number is always going to be your remainder. If you're doing any division, whether it's long division, short division, I mean, not short division, but synthetic division, that last number will always be your remainder. So that doesn't change. Just like this is still my quotient. you know, the answer part is what I call it, but it's still the quotient. It's just that we're using the quotient to establish the slant asymptote, you know, so, yep. All right, is everybody good? Everybody straight? Well, yeah, that's all I got. That's all I got, guys. That's it. I know that's kind of weird because I normally hold you longer than that, but that's all that one section is. And you know, we don't necessarily have to rush. We're in a good place as far as the lecture is concerned. Then, like I told you, I do have to go hit this dentist up, you know, for an enjoyable morning. But before I close out, are there any questions? So I said we done.
Real quick, are you gonna post the Zooms from last week?
I didn't do that.
Behind. No, you didn't.
Oh man, I'm slipping. Had a whole bunch of stuff going on this weekend, so I completely forgot.
Okay.
I will do that.
He didn't
today.
respond to emails this weekend either.
Nah, man, this weekend was crazy. Y'all just don't understand. I know y'all got lives, but I got one too, and
No, it's understandable.
it kicked in this weekend, so I apologize for that. Like when you said that, I hadn't even thought about that. I didn't do it, so it wasn't just y'all. That was everybody. Everybody got that got that into it this week. So I apologize. Thank you, because you just reminded me that I didn't do it. Is the unit
Okay.
due on the 20th? Yes, week 2 work is due on the 20th. So that was you know, by request from Mr. Bracy. So I made that happen for you guys. If there are any issues with submissions, if there are any issues with Math Lab and all that, let me know. And I will get back to you because now it's the week. You know, the weekday has started. But this weekend was, yeah, family and whatever all decided to descend upon me. And then I found out I had a disappointment on Monday. So
I hope you're doing well, man.
oh yeah, man, I can always smile about it, man. As long as everybody's still alive and everybody's all right, I'm gonna be all right. But you know, life happens, man. So you gotta operate accordingly. So yeah, let's see. So now your grade in Math Lab, somebody said is the Math Lab grade, your actual grade. If you've done everything you're supposed to do, your grade should actually be higher in my book than what is in my Math Lab. Because don't forget, I boost up your homework grade. If you have a 75, that goes up to a 90. If you have an 85, it goes up to 100. And so I preference the comment though with if you do everything you're supposed to do. Because let's say if you haven't attempted a test or haven't even gone into it, Math Lab sometimes doesn't count it against you at that moment. You know what I mean? So you have a 0 for a test, but it hasn't been counted against you. But of course, I have to count it against you. You know what I mean? So if you've done everything you're supposed to do, your grade in Math Lab will be higher in my book than in Math Lab. Test reviews will not count against you, right? No matter what you do with the test, whether it's a 0 or if you just went in there, peaked a little bit and got a 15% on it, test reviews will not count against you. They can only help you if you were to score, that grade of 85 or better. Not a problem, not a problem. Anything else, anybody else before we close? Those emails, I knew I was coming up short on that, so I was going to make sure I address those today. So if you send me an email over the weekend, I'll get to it today, and I'm gonna shoot the videos out to today as well. So it's not graded. No, the test review, I use it as extra points towards your test. So if you score 85 or better, I add 5 points to your test. So that's how the test reviews work. So Math Lab will probably count them because that's just embedded in the system. It's probably a way I can go in there and omit stuff, but I mean, it ain't a big deal. I'm gonna do it when I do my manual grading anyway. So, all right. Anything else? Anybody else? Everybody good?
And you said you should be here for the office hours today?
Yep.
All right, cool.
All right, guys. You guys have a good one. Be safe, and I will see you on Wednesday. All right.
All right, have a good one.
Yep. Take care. Appreciate it.
Have a good one, sir.
Thanks. You do the same.
Too. Have a good day.
Take care. Thanks. All right.